Welcome to Core of Space. Our journey is start. The planets in our solar system often steal the show, but lurking in their orbits are worlds just as strange, moons with secrets deep beneath their surfaces. Today, we're diving into the three most mysterious moons that could hold the key to alien life: Europa, Titan, and Enceladus. We'll journey to ice-cracked oceans, methane rains, and icy geysers. We'll explore their discovery, composition, recent research, and what's next, or could be next, in their exploration. Europa, the ocean moon. When we think of life beyond Earth, we often imagine distant planets orbiting alien stars. But what if one of the best places to find alien life is right here in our own solar system? Meet Europa, a small, icy moon orbiting the giant planet Jupiter. At first glance, it looks cold, cracked, and lifeless, but beneath that frozen shell lies one of the most mysterious and promising oceans in the universe. Europa was discovered in 1610 by Galileo Galilei. It's about 90% the size of our moon, but it couldn't be more different. Its surface is a thick layer of ice, bright, smooth, and marked with long reddish fractures. But here's the twist. Scientists believe that under this icy crust lies a massive subsurface ocean, one that may hold more water than all of Earth's oceans combined. This hidden ocean isn't just frozen in place, it's kept liquid by a fascinating force: tidal heating. As Europa orbits Jupiter, the planet's immense gravity pulls and stretches the moon. This constant flexing produces internal heat, enough to melt ice deep below the surface. The result? A global ocean, possibly 100 kilometers deep, sealed beneath a crust of ice. Dark, cold, and full of mystery. On Earth, life has been found thriving in total darkness, around hydrothermal vents deep in our oceans. These ecosystems don't need sunlight, they use chemical energy from the planet's interior. Europa could have similar vents on its ocean floor. And where there's energy, water, and the right chemistry, there could be life. We're not talking about space whales or sea monsters, but maybe simple organisms, bacteria-like life forms, adapted to Europa's strange, salty sea. And if life exists there, it would be independent of Earth, a second Genesis. That would mean life isn't rare, it might be everywhere. Europa's surface gives us more clues. Those reddish lines? Scientists think they're rich in saltson. Evidence of the subsurface ocean, Europa. What if one of the most promising oceans for alien life wasn't on Earth, or even on a planet, but hidden deep beneath the icy surface of a distant moon? Welcome to Europa, one of Jupiter's most fascinating moons, and the leading contender in our search for extraterrestrial life. Europa may look like a frozen, lifeless ball of ice, but for decades, scientists have been gathering clues that something incredible lies beneath its crust. A vast, liquid water ocean. The first major evidence came in the late 1990s, when NASA's Galileo spacecraft flew past Europa. It detected something unusual in the moon's magnetic field, a signal that hinted at a conductive layer beneath the surface. And what conducts electricity better than anything else? Salt water. Europa's surface is crisscrossed with giant, reddish cracks and fractures, almost like a shattered eggshell. These cracks aren't random. They match perfectly with predictions of how tidal forces from Jupiter would stretch and squeeze Europa over time. That stress creates frictional heat, which keeps the ocean below from freezing, even though surface temperatures can drop below -160 degrees Celsius. Imagine this. Beneath 15 to 25 kilometers of ice, there could be an ocean 100 kilometers deep, containing more than twice the water found on Earth. And this ocean is likely in contact with a rocky seafloor, just like our own oceans, opening the possibility for underwater vents and chemical reactions that could support life. Just like deep-sea vents on Earth, Europa might have hydrothermal activity at the bottom of its ocean. These environments on Earth host entire ecosystems, powered not by sunlight, but by chemistry. If similar vents exist on Europa, life could be possible. In 2012, even more compelling evidence emerged. The Hubble Space Telescope detected signs of water vapor plumes erupting from Europa's surface. That means the ocean may not be locked away forever, it could be leaking into space, carrying clues about its chemistry, or even its biology. NASA's upcoming Europa Clipper mission will dive deeper into this mystery. Launching in 2024, it will use radar and spectrometers to study the Moon's ice, magnetic field, and surface chemistry, searching for the "we haven't even landed on Europa yet, but the signs are everywhere." Cracks in the ice, heat from within, salts and water vapor escaping into space. If there's an ocean under Europa, and all evidence suggests there is, it may be one of the best places in our solar system to search for life beyond Earth. Potential for life, Europa. What if we're not alone in the solar system, not in some distant galaxy, but just a few 100 million miles away, beneath the icy shell of a moon called Europa? Europa, one of Jupiter's largest moons, holds one of the greatest mysteries of our time. Beneath its frozen surface lies a vast, dark ocean. And where there's liquid water, there might be life. Scientists believe Europa's ocean could be 100 kilometers deep, more than twice the volume of Earth's oceans combined. But it's not just the water that excites scientists, it's the energy and chemistry happening down there. On Earth, deep in the oceans, far from sunlight, life thrives around hydrothermal vents, cracks in the seafloor where hot, mineral-rich water flows out. Microbes feed on chemical energy, and entire ecosystems grow around them, no sunlight required. Europa might have the same kind of vents on its ocean floor. If that's true, then life could exist there. Not just possibly, but plausibly. It might start small, single-celled organisms, alien bacteria swimming in the salty dark. But even that would change everything. It would be a second Genesis, life that didn't come from Earth. Europa's surface tells us even more. Scientists have detected salts, organic compounds, and reddish stains that could be remnants from the ocean below. This suggests there's a connection, maybe water from below seeps up, or even erupts in plumes. In fact, NASA's Hubble telescope has detected possible plumes of water vapor erupting from Europa. If confirmed, we could one day fly through those plumes and analyze them, without even landing. That means we might be able to detect signs of life, from orbit. NASA's Europa Clipper, launching in 2024, will investigate all of this. It'll fly by Europa dozens of times, scanning for heat, ice thickness, and chemical signs of life. It won't land. But it could bring us closer than ever to answering an ancient question. Are we alone? If life exists beneath Europa's ice, even a single microbe, it would mean life isn't rare, it's common. And maybe. Surface features and chemistry, Europa. It looks like a frozen wasteland from afar. But Europa's surface holds secrets, not just of its violent past, but possibly of life hidden beneath its icy skin. Europa is one of Jupiter's most mysterious moons. Its icy surface is unlike anything else in the solar system, smooth, cracked, and strangely young. Unlike the crater-covered faces of most moons, Europa's surface is relatively smooth, and that tells us something important. The surface is constantly changing. It's made almost entirely of water ice, and it shows evidence of recent geological activity, possibly driven by the ocean below. The most striking features? Long, reddish-brown fractures and ridges that stretch for thousands of kilometers. These form when Europa's icy shell cracks and shifts, due to powerful tidal forces from Jupiter. It's almost as if the ice is floating and moving, like tectonic plates on Earth. Then there's something even stranger. Regions known as chaos terrain. These are jumbled blocks of ice, rotated and tilted, like broken puzzle pieces frozen in place. Scientists believe these might be places where the ice melted from below, then refroze, suggesting interaction between the surface and the ocean beneath. But the chemistry is where it gets really interesting. Those reddish stains along Europa's cracks and chaos zones? They may be salts, pushed up from the ocean below. NASA's Galileo spacecraft found evidence of magnesium sulfate and other salts, the same types found in Earth's ocean water. Even more exciting, some of these materials might include organic molecules, carbon-based compounds, this means Europa's icy crust isn't just a barrier, it could be a chemical bridge. Materials from the ocean may be reaching the surface, and surface materials may be falling back down, mixing chemistry from both worlds. That cycle is important. It keeps the ocean active and evolving, a key ingredient for life. NASA's upcoming Europa Clipper mission will scan these surface features in stunning detail. Its instruments will detect salts, organics, and maybe even signs of life-related chemistry. It'll also study how thick the ice is. Europa's surface may look frozen and silent. But every crack, every chemical trace, tells a story of movement, exchange, and the possibility of life below. Atmosphere and surface, Europa. At first glance, Europa looks like just another icy moon in the outer solar system. But look a little closer, and its surface and atmosphere tell a story of movement, mystery, and maybe even life. Europa is one of Jupiter's 4 largest moons, and possibly its most fascinating. Its surface is a world of ice, cracked, streaked, and glowing faintly under Jupiter's magnetic grip. Unlike crater-filled moons like Callisto, Europa has a smooth, bright surface, made mostly of water ice. It's covered in long ridges, fractures, and chaotic terrains, clear signs that the surface is geologically active. These features form when the icy crust flexes and cracks due to powerful tidal forces from Jupiter. But this icy surface isn't just frozen solid. Beneath it lies a liquid ocean, and there's strong evidence that materials from below can rise to the surface, creating reddish stains and strange terrain. Some of these surface features are rich in salts and possibly organic materials, pushed up through cracks. These dark lines and patches may contain hints about Europa's internal chemistry, and possibly, conditions that support life. But Europa isn't entirely airless. It has a very thin atmosphere, composed mostly of oxygen, but not the kind we can breathe. This oxygen doesn't come from life, it forms when sunlight and charged particles hit the ice, splitting water molecules into hydrogen and oxygen. The hydrogen escapes, and the oxygen lingers. Jupiter's powerful magnetic field plays a big role here. As Europa orbits, it gets bombarded with radiation, constantly reshaping the chemistry of its surface and atmosphere. This radiation also breaks down molecules, which may help scientists detect signs of salts, organics, and even potential biosignatures in future missions. NASA's Europa Clipper, launching in 2024, will fly by Europa dozens of times. Using advanced instruments to study both its surface and its atmosphere. It will analyze the ice for composition, thickness, and possible water vapor plumes escaping into space. Europa may seem distant and quiet. But its surface tells of an active world, constantly reshaped by forces within. And its thin, ghostly atmosphere hints at deeper processes we've only just begun to understand. Future exploration, Europa. For decades, we've stared at Europa from afar. A frozen moon, cracked with mystery, hiding a vast ocean beneath its icy shell. Now, the question isn't if we'll explore Europa, but how soon.
8, 7,
Europa,
6,
one of Jupiter's largest moons, is a top contender in the search for alien life.
1.
And finally, after years of planning, humanity is preparing to take the next step. NASA's upcoming mission, the Europa Clipper, is set to launch in October 2024, and it's the most advanced mission ever sent to this distant moon. The spacecraft will arrive in the early 2030s and conduct nearly 50 flybys of
Houston
Europa,
now controlling
gathering
Atlantis on its
high-resolution
way.
data from just 25 kilometers above the surface. The Europa Clipper is packed with powerful instruments. Radar to penetrate the ice and map the thickness. Spectrometers to detect salts, organics, and surface chemistry. Magnetometers to search for signs of the hidden ocean's depth and salinity. One of the most exciting goals.
Dynamic pressure.
To fly through possible water vapor plumes erupting from Europa's surface, and directly analyze the material. If those plumes contain organic molecules, we might find the first clues to life beyond Earth, without even landing. But that's just the beginning. NASA is already studying concepts for a Europa lander, a robotic explorer that could drill into the ice and study samples up close. In the long term, scientists even dream of a cryobot, a robotic probe that could melt through Europa's icy crust and reach the ocean below. It sounds like science fiction, but step by step, it's becoming real. Meanwhile, Europe is also joining the mission. The ESA JUICE mission, short for Jupiter Icy Moons Explorer, launched in 2023 and will arrive in 2031, studying Europa, Ganymede, and Callisto. Together, these missions mark a new era of exploration around Jupiter's icy moons. Europa may hold the answers to one of humanity's oldest questions. Are we alone in the universe? And now, with eyes, instruments, and vision focused on this frozen world, we are closer than ever to finding out. Ocean and hydrothermal activity, Europa. Imagine an ocean, deeper than all of Earth's combined. A place with no sunlight, sealed beneath miles of ice. And yet, possibly alive. This isn't science fiction. It's one of the most intriguing possibilities in our solar system, hidden beneath the surface of Europa, Jupiter's icy moon. Europa's surface is frozen solid, with temperatures dropping to -160 degrees Celsius. But deep beneath its icy crust lies something extraordinary, a global subsurface ocean. Scientists estimate it could be between 60 to 150 kilometers deep, making it possibly the largest ocean in the solar system. This ocean isn't sitting quietly. Thanks to intense tidal forces from Jupiter, Europa is constantly being stretched and compressed as it orbits the gas giant. That flexing creates frictional heat inside Europa, enough to keep its ocean from freezing, despite the extreme cold above. And here's where things get even more interesting. That heat may be fueling hydrothermal activity at the bottom of Europa's ocean, just like the vents found on Earth's seafloor. On our planet, these vents release superheated, mineral-rich water, and life thrives around them, completely independent of sunlight. Could the same be true for Europa? If Europa has similar hydrothermal vents, they could provide the chemical energy needed to support life, even in total darkness. Scientists believe chemosynthesis, where microbes convert chemicals into energy, could power entire ecosystems beneath the ice. In fact, data from missions like Galileo and Hubble suggest that Europa's ocean might be in contact with a rocky seafloor, a key requirement for hydrothermal reactions. And in 2019, scientists detected signs of hydrogen and possible organic molecules in water vapor plumes escaping from Europa, hinting at active chemistry, and maybe even life-friendly environments. NASA's upcoming Europa Clipper mission will take this investigation to the next level. Using ice-penetrating radar, magnetometers, and spectrometers, it will map Europa's subsurface, searching for clues of liquid water and thermal activity. If the data confirms active hydrothermal systems, it would be one of the strongest indicators of habitability in our solar system. Europa's hidden ocean could be a cradle of alien life, warm, active, and thriving. And don't forget to subscribe to the Core of Space for more space-informative videos.